Okay, so today is 3.7 motion, and we're working on day 2. So we're actually going to look at the exact same 4 problems we looked at yesterday, and we're going to solve them. Okay, so yesterday we took notes about which diagram and formula do we use and all those things. So you might want those notes out from yesterday to help you so we can get started actually solving the problems now. Okay. So for example 1, we had the junior high and high school Sunday school classes were going on a hike. The junior high class leaves the church and travels east at 3 miles per hour. The high school class leaves an hour later, traveling 5 miles per hour on the same route. How much time will pass before the high school class catches up with the junior high class? Okay, so we decided yesterday that we should use which formula? Okay, so the same distance is the round trip or pursuit, right? Okay, so we're going to use the round trip or the pursuit, which means what? What was our equation going to look like? What did we say we were going to? Well, D1 plus D2, but we said D1 plus D2? That was not the round true. D1 equals D2. Okay, but what did we say the equation was for our problem? Instead of just D1 is distance 1 equals distance 2. Okay, so the junior, right, high equals the high. That was what we were going to do. Okay, the junior high equaled the high school. All right, so when we're looking at our chart, we're trying to fill out our chart with this information. We're drawing the picture, the diagram. We could draw that again to help us. If we need to get information from there, we can try to just fill out the chart. But, so how do we want to go about this? What's the easiest way? Like, we've been working on charts for several days now. So what do you think goes where? For what? Like you have no labels in your chart. Like, yes, 5 miles an hour is a rate. Okay, so we have a column for some labels. So we've got junior high and high school. And so you said 5 miles an hour is the rate for which one? Okay, so 5 miles an hour is the rate for the high school. The 3 is the rate for the junior high. Okay, so that's great, right? Because the junior high class leaves the church and travels at 3 miles per hour. The high school class leaves an hour later, traveling at 5 miles per hour. $60 minutes for the time. Okay, so they left an hour later. Yes. So we do have an hour more or 60 minutes more. This is true. Well, okay. What do you mean by that? Okay, so do you know how long it took? Like it says how much time will pass before they catch up. Do you know how much time it took for them to catch up? No. Okay, we would put a variable. All right, so that's the thing. That's the thing we're looking for. Right? It says how much time passed. So we know we have to have a variable in our time. Which one, where do you want to put the variable? You want to put it with the junior high or the high schoolers? The junior high? You can put it in either place, but where you put it is going to affect the other like the other row. Okay, so we can do it both ways. Like, okay, that's fine. We'll just reassess it in a second, and I'll show you why. So we have the rate, the time, and the distance. Okay, so we have, I really need to calibrate this board. Okay, so we can do it either way. All right, so but we need to talk about it. So Junior wants to put the variable here with time. I was trying to change it to a different color. And Anne wants it here with the high schoolers instead of the junior highs. Okay, so let's go back here so it's not good. All I'm saying is it's going to affect our equation. It's not wrong to put it in either place, but we have to think through what it means. Okay, so what is the time in this situation? Okay, so not the actual numerical value. Give me a definition of time. What does time mean here in this situation?
Like how long it takes something.
Okay, so the time here is how much time will pass before the high school class catches up. Okay, so time is how much time it takes for them to catch up. So how much time they're in the hike, right? Okay, so is our time. That's what we're thinking about. So what we also know that the high schoolers left an hour later. So what is their time in relation to the junior high time? They left an hour later. Okay, so what does that look like numerically or mathematically? Is their time the same as the junior high schoolers' time? No. So is it an hour more or an hour less if they left an hour later? And you're the last one to vote. So I'm saying if time is that the junior high walked for this amount of time, we're trying to figure out the high schoolers' time in relation to that. So do the high schoolers hike for an hour more or an hour less? They left 1 hour later. They'd have to hike more. So they're hiking longer? Anne's back there shaking her head. They would have walked, okay, so they're walking the same distance.
It would have taken the high schoolers more time to catch up with them because they started earlier, so they're already an hour ahead of them on their hike. So then the junior highs they don't have to go on. And it would be less time.
Okay.
The junior high has to make up that hour as they're hiking. So unless they walk much faster than the but still it would.
Okay. Junior, come here.
Yeah.
So I want you to start walking to the back of the class. Did I leave at the same time as him? Did I walk the same distance as you?
Yeah.
Who walked for a longer amount of time? Junior walked for longer because I started later. Does that make sense? Because we're confusing time with distance and speed. Okay, so like I'm gonna start walking, Junior, and you catch up to me, okay? So you stay behind, leave later. I'm gonna start walking and then you start catching up to me. Okay, so I left before you. So you left later, but you caught up to me. It forced you to walk faster, but we walked the same total distance. Okay, but who walked for a longer amount of time? Me, because I left first, right? I started walking and you got to just hang out at the back wall and be like, ha ha, look at her go walk. Okay, so that's the thing about time. If the junior high school class is hiking for T amount of time and the high school class left 1 hour later, what is their time? How would we describe their time numerically? Is it the same as the junior high? No, it's less. Okay, when they left later, it's less by how much? No, that's miles is distance. We're talking about, okay, it's less by 1 hour. So here, Our time would be t minus 1. It's the time that the junior highs walked, but it's minus 1 hour because they walked for 1 hour less. Does that make sense? Okay, so that's the thing with these problems. We really have to take the time to separate rate from time and from distance, because you guys were right. Like Junior was explaining, well, they have to walk faster to catch up. Yes, they do, but they're walking for a shorter amount of time. Okay, now if we look at Anne's scenario, she's saying that the high schoolers walked for t amount of time. Okay, so if we're putting the t, the variable, with the high schoolers, and t represents how long the high schoolers walked, how long did the junior high school class walk in relation to the high school class? So remember, the junior high school class left, right? So the junior high class left, starts walking. Then we have 1 hour later, right? 1 hour later, the high school class leaves and starts walking to catch up. So Hayden, you're saying this, in this case, the junior high class walked the same amount of time that the high schoolers walked, but they walked 1 hour more. T plus 1, you're saying they walked 1 hour more? That would be correct. Okay, so both of these are correct. Both of them are going to get you the right answer when you solve the equations for them, but it does, so it matters where you put your variable because it's going to change what the other one is. Okay, so if you're doing your homework and you're like, well, wait, I didn't get that equation, don't think that it's because you set it up wrong. Okay, that would, I say, that's the tendency, is to think that, like, I set it up wrong. Like, what did I do wrong? There's not necessarily anything that you did wrong. It's just you're thinking, the way you're thinking about it might be different than the way someone else is thinking. Okay, so let me erase this here. All right, so where would we go from here? Then we have to find the distance. Okay, so let's go to our first table. So what's the distance here? For the junior high, 3 times t is 3t. Okay, and what about for the high schoolers? Okay, so it's 5 times the quantity t minus 1, which would be 5t minus 5. I didn't make my box big enough, apparently. Okay, so these would be the distances that I'm going to set equal here. So I would say 3t equals 5t minus 5. Did you just say we had to put them together? Okay, I was like, not put them together, right? Like you already said, this was round trip, and so we're going to set them equal to each other. So our distance for the junior high equals the distance for the high schoolers. I could get my color. I don't know why my color won't change here. Yep. So then here we would have 3t plus 3, right? We distribute. Here we would have equals 5t. And so we would set those equal. 3t plus 3 equals 5t. Do these equations match? No, they don't. They don't look anything alike, but they're gonna get you the same answer. Okay? Yes. Okay, yes, they will get you the same answer. All right, so let's go back. Let's solve juniors first. Okay, so how would I solve 3t equals 5t minus 5? I mean, I can add 5 to both sides. There's nothing, I mean, like, it's an okay strategy. It's just not going to get me anywhere. I'm just going to have 3t plus 5 equals 5t now. Well, because you said add 5, because this was minus 5. So I just moved my 5 to the other side. I didn't, that's why I'm saying it's not wrong. Any of your steps, if you do them right, aren't wrong. They just may not lead you any closer to the answer. You're just working in circles. So what would I do next? Like terms? Okay, what would I do with my like terms? Subtract 3t from both sides. Okay. So then I have 5 equals 2t. Then what? Are you writing this down? Okay. So what do I do next? I do divide by 2. Okay, Leah, it's going to give me what? That's okay. Nobody said it had to be a whole number, right? So 5 over 2 is 5 over 2, or it could be 2 and 1/2. You can have 2.5. All of these equal t. And remember, t here is the time that the junior high class hiked. Can the junior high class hike for 2.5 hours? Yeah, that's okay. So it's fine to have 2.5. So t is 2.5 hours. Okay. The question, however, says how much time will pass before the high school class catches up with the junior high class? So how do we, huh? Well, you solve for t, right? What's the t? What was it? 2.5. Okay. So is that how much time passed before the high schoolers caught up to the junior high class? No, your t, remember, was how long the junior high class hiked. No, the junior high class hiked for 2.5 hours. So,
Okay, so then we divide by 5?
no,
Divide by 2.
I don't have any. No. Okay.
Divide by 3.
Okay, well, I'm going to pause it and let you all think about it, and I'm going to answer Josh's question. All right, so you had the epiphany. Like, we found t. That's how long the junior high class walked, but we still have to figure out the high school class. So yeah, you take the 2.5 and you subtract 1 hour, and that's going to equal the t for the high schoolers. So 1.5 hours is the high schoolers. Well, I shouldn't put that equals t. That would be false. Right, because it's t was 2.5 minus 1, so this equals the high school time. So yeah, the high schoolers walked for an hour and a half. The junior high walked for 2.5 hours. You should. Yeah. Okay, because I mean, if you're using one variable for both places, then yes. Okay, so let's look at this, the Anne's way that she set it up. So how would we solve that? Okay, so how would we get our like times together? Subtract 3t. So then we have 3 equals 2t. Then we divide by 2. 1.5 equals t. And this time t is how fast the high schoolers, or how long they traveled. Did the high schoolers travel for an hour and a half over here? Yes. Okay, it's just our t is in a different place. So our junior high, they traveled for t plus 1, right? What's t here? So 1.5 plus 1 equals 2.5 hours. Did the junior high class travel for 2.5 hours over here? Yes. Okay, so that we get the same thing. Each time we're going to get the same thing. It's just the setup can be different, and it makes a big difference. Okay, good. Does everybody have this one down? Okay. Then let's look at number 2. All right, so 2 trains leave Mattoon at the same time. The northbound train travels 5 miles an hour faster than the southbound train. What is the rate of each train after 3 hours if they are 333 miles apart? Okay, so yesterday, which diagram did we say we needed to use? Okay, it's not called the sum distance. It's called the opposite direction. Okay, so they traveled the opposite direction, which means that we do sum their distance. So what's the equation? What equation did we have yesterday? Okay, so the southbound plus the northbound distance is going to equal 333 miles. Good. All right, so we are going to have to come back to this idea after we fill out the chart. Okay. All right, let's do it. So we've got S and N, the southbound and the northbound train. Oh my goodness. Okay, the rate for the northbound is 5 miles an hour. So that's our northbound train. Is it 5 miles an hour? Ooh, it's 5 miles an hour faster than the southbound train. So this is not just going to be 5. Okay, so the northbound train, we want to do 5 plus S. Is that what I heard? Okay, so then I heard 5 plus R because it's the rate. It does not matter at all to me if you use S or R. Okay, that's perfect. So then, what does that tell you about the rate for the southbound train? So, okay, so you're using R. So then for us, it would have to be just S, right? If we're taking the rate that the southbound train traveled, and we're adding 5 to it for the northbound train. Okay, so yeah. For which one? For both, right? What is the rate of each train if after 3 hours okay, so they both traveled 3 hours because they left at the same time. Distance is 333 miles. Well, that's our total distance. Okay, this distance, right, so that distance would be their total. That's 333. Okay, because we're summing them, right? We're showing that we're going to sum them. This distance is where we put these two things together, the rate times the time, to get that expression. So we've got 3S here. No, we have to distribute, right? This is like 3 times the quantity, 5 plus S. 15 plus 3S. There we go. Okay. Now, you already had the understanding yesterday of how to set up this equation. And you have it here. You're saying combined, their distance is 333. So we need to add the distance of the southbound train to the distance of the northbound train and set them equal to 333. Okay, do you guys agree with that? We're good with that? Okay, perfect. Then how do we solve it? Oh, we can just add our like terms this time, right? Because they're on the same side of the equation. That's nice. Okay, so 6S plus 15 equals 333. What next? Okay, if I subtract 6x, just think through that, then we would have, no, then we would have 15 equals 333 minus 6s, right? Okay, so maybe, again, so the step's not wrong. We can do it. It's just not going to move us forward in our problem. Subtract 15 on both sides, because that would be a like number. Good. So then 6s equals, so if we subtract 15 from both sides, we have 6s, or in your case 6r, equals 318. Okay, Leah, what would we do now? Perfect. We would divide 6 on both sides. I heard 53. Did I hear confirmation for that? Okay, so S is 53. What? What's the rate? What's the unit? Miles per hour. Good. So the southbound train is traveling 53 miles per hour. The northbound train is traveling what? 58, because we took 53, the southbound, right? Because we had S plus 5. So the southbound plus 5 is 58 miles per hour. Perfect. Good. So you found the rate of each train. Very good. All right, does everybody have this one? All right, John, the senior on the track team, runs at a training rate of 375 meters per minute, while Paul, a freshman, trains at 325 meters per minute. How long does it take for John to lap Paul if they are training on a 400-meter track? And how many laps has each run during this time? So yesterday when we talked about this, which formula do we use? Okay, so the given distance we have is shorter. Okay, this case it's actually longer, isn't it? Okay, so the given distance is longer. Either way, it's the same idea. Okay, so what equation did we end up with yesterday? So John's time equals John's distance equals Paul's distance plus 400. Okay, very nice. All right. We can put J and P for John, right, and Paul. Good. Okay, who's that for? Okay, so this is John's rate, 375. Okay, so that's Paul, 325. We don't know the time. We know the distance. Okay. So, what's the distance? We don't know that's 400. We know he lapped him, right? Okay. So John, a senior on the track team, runs at a training rate of 375 meters per minute, while Paul, a freshman, trains at 325 meters per minute. How long does it take for John to lap Paul if they're training on a 400-meter track? But that's the distance. Remember that that he's lapping him. That we have this 400 because he's lapping him. That's the lap longer. So what do we think? Would the 400 go on the outside? What do you mean it would go on the outside? like we did before. But the 400 is not the total distance that both of them traveled. Because remember, this means that in that diagram, it's the distance of 1 equals the distance of the second person plus the 400 meters more. So the distance that John ran is equal to the distance that Paul ran plus 400 meters because John lapped him. Like he ran around, like if we're running around the table, he ran around the table one more time than John did. Okay. Huh? We don't know the time that they ran. This is true. So we can use a variable for the time. What do you guys think about that? Can we use a variable for the time? You don't know? Okay, so think about the time. Do they run for the same amount of time?
Yes.
Okay, I hear 2 confident yeses, and then I'm like, I don't know. Okay, so the whole point is that we're trying to run, right? John is senior on the track team, runs at 375. Paul runs at 325 meters per minute. How long does it take for John to lap Paul? If someone is lapping you, do you have to start the race at the same time or do you start at a different time? The same time, right? That's the only way that they can truly lap you. So the time that John ran and the time that Paul ran, is that the same or are they different amounts of time? Same. Okay, so then we could say this is T and this is T. So the distance that John ran is 375 times T, and the distance that Paul ran is 325 T, right? We're just taking how fast they ran, their rate, multiplying it by how long they ran. The trick comes here when we take into that account that it's that 400 meters. So how are we going to set up our equation? So 375T is John's time equals Paul's time, so 325T plus 400. In order for Paul's time to be, or Paul's distance to be equal to John's, we take his distance plus the 400 that he didn't run, okay, to make them equal. Okay, if you subtract 375T, right, you're going to move the 375 over here and you're going to have 0 on this column, like on this side of your equal sign. Again, it's not wrong. Let me just show you. Don't write it down. Let me just show you what I'm talking about. 375 minus 375 is 0. Then I have an equal sign. Equals negative 50T plus 400. Did it get me closer to solving? Okay, so again, not wrong per se, but it doesn't get me closer to really finishing my equation necessarily. There we go. If we subtract the 325T, then we'll have the T's, right? We'll have 50T equals 400. Then we have them 2 different things on, or the T on one side and the constants on the other. All right, good. Now we divide by 50. I heard an 8. Everybody confirm 8? 8? Okay, what's my unit of measurement?
Meters per minute.
Time. It's time. The rate was meters per minute, so which of those is a measurement of time? Minutes. So T is 8 minutes. And this is how long they both ran, right? let's see. So how long does it take? We answered this first question. How long does it take for John to lap Paul if they are training on a 400-meter track? Okay, 8 minutes. Then there's a second question. How many laps has each run during this time?
Would you divide by 2 if he runs?
So we have that one more question there. How many laps has each run during this time? How can you solve that? What would you divide it by? Not quite. Okay, so
would you do
you're close.
Would you do 375 times 8 divided by 400?
Why would you do that?
Because John runs 37 centimeters in a minute. If he's ran for 8 minutes, multiply that to see how many meters he's ran in 8 minutes, and then you'd have to divide that 400.
Okay, so you're saying if we take, so this is for John, first of all. If we take the 375 meters per minute and we say he ran for 8 minutes, that's going to give us how many meters he ran. In 8 minutes. Okay, and we're dividing by 400 because a lap, 1 lap equals 400 meters. Okay, so you're saying this is equal to 7.5? All right, that would be correct. So 7.5 what? No. Laps, right? Because he ran 375 times 8 is how many meters he ran. So this is 7.5 laps. Nice. Okay, good. So then how many laps did Paul run? You could do the same thing. That's what you would do? Okay, so you would do 325 times 8 divided by 400 equals 6.5 laps. Okay. Does anybody see any other way you could solve that? What was John supposed to do? Wasn't he supposed to lap Paul? Which meant to run one more lap? So if he ran one more, we could have just subtracted 1. Yeah, we could have. And that is okay. Like, it's totally fine, right? Sometimes we get so caught up in the math, but that's it. Like, word problems require critical thinking the entire time. You can't just set up the numbers and solve. And that is the difference between solving an equation and figuring out a word problem. You have to critically think and analyze the whole way through. All right, we've got one more to think our way through. There you go. All right. Let's clear. All right, last one is Mr. Rogers leaving Roseville for Milltown, traveling 48 miles per hour. Mr. Brown leaves Milltown for Roseville at the same time, traveling 50 miles per hour. If Roseville and Milltown are 294 miles apart, how long does each man travel before they meet? Opposite direction yesterday. Good. All right. Was what? R plus B equals 294. R was Mr. Rogers, right? B was Mr. Brown's distance. And 294 was that total distance they were apart. Perfect. Okay, so we can put R for Rogers, B for Brown. Yep, 48 for who? For Rogers, okay. Okay. We don't know how long. 294 would go outside the box. Good. Okay, for both of them? Why? Yeah, but we didn't know the time for either of the junior high or the high school classes hiking, and we had two different variables.
Well, that's because on that one, they started at 2 different times.
They started at 2 different times. So what do we know about this one? You're right. You had it. He just cut you off, right? It's okay. So this time they left at the same time. Okay, so they do have that. So what's our distance here? 48t and 50t. So, Anne, what's our equation going to be?
48t plus 50t.
Yep. Great. So do you see how yesterday spending this time just thinking through the problem, drawing the diagram, understanding it, it's making you all so much more prepared for today. And
then you add subtract
we're going to add like terms because we're on the same side. Good. So 48 plus t plus 50t. 98t equals 294. Divide 98 on both sides. 3 hours? Anybody confirm 3 hours? Okay. You got 3 hours? Okay. Okay. So, how long does each man travel before they meet? 3 hours. There's just one question there. So, Anne, I guess I lied to you. You said, are they all going to have 2 answers? And I said, pretty much. Or I said, yes, I think.
You said pretty much.
Okay. So, I stand corrected. They basically do. So, yes. There you go. I was technically sort of right. All right. So then you can go ahead and get started. Remember, you're only doing the odds today. 11 through 25. You only have 3 minutes. Okay.